Thanks a ton for coming to this late session on Thursday. I know you guys had a long day, so greatly appreciate you guys showing up. Means a lot to us on the service team who've been working pretty hard to get you guys this service. I'll start with a quick introduction. My name's Abhishek Singh. I'm the principal product manager in the developer and management tools organization. I lead product management for X-Ray and for Elastic Beanstalk. So today, just to give you guys a quick overview of what we expect from the session, we'll start with the overview of the service, why we chose to build the service, what the service does, what problems it solves. We'll look into the concepts that the service provides. We'll talk about the APIs and how you can do a lot more with the service using the APIs than you can with the clients today. We'll look into the use cases that the service is built to satisfy. And then we'll look at what it takes to get started using the service. We'll do a live demo if technology cooperates. And then we'll talk a little bit about sample applications and documentation and links of that sort so that you guys can go back and get started with using the service. So X-Ray was essentially conceived to solve the problem of debugging applications. We started with essentially debugging and development, if you will, where traditional debugging involves a development environment, involves searching through your logs, finding the right pieces to be able to replicate the issue that you're seeing, setting breakpoints to stop code execution, and then inspecting the call stack and the variables, if you will, adding additional log statements if you haven't captured the appropriate data, and then repeating this process until you're able to diagnose the issue that you have at hand. The traditional process of debugging doesn't really scale well in production applications in the cloud. Specifically these days with applications being built using a service-oriented model, microservices, or serverless model, if you will. It really is tedious, repetitive, and time-consuming. Let's also look at another paradigm shift that's ongoing, which is why the X-Ray service is really important. We're seeing more and more of our customers move from monolithic architectures to service-oriented and serverless architectures. The applications were originally developed as monolithic architectures for few benefits, and they also had their own drawbacks. The move to microservices essentially addressed a lot of the drawbacks, if you will, of monolithic architectures, but they introduced their own set of challenges. So some of the challenges with microservices architecture, with serverless architectures, is that deploying and managing them can be more time-consuming or more work compared to monolithic applications. But that gives you a lot more agility, and there's a lot of benefits in moving towards, microservices or serverless architectures. Services such as Lambda, the EC2 container service, Elastic Beanstalk, and CloudFormation make it very easy for you to manage hundreds of services or deploy applications that consist of hundreds of services. But it's still very hard to debug application issues, specifically in production applications. This is mainly due to cross-service interactions. So now you've got a request that originally was processed on a single host, traveling across the network on multiple hosts, multiple services. You have to keep track of the piece of data, essentially, and tie it together. There's varying log formats. So with microservices, developers, essentially, and organizations have embraced the ability for developers to choose their own application stacks. So you might have a microservice running in Java, another one running in Node, and another one might be running in .NET. And all of these produce different or varying logs, which are very hard to normalize and collate. The third point why debugging in distributed systems is hard is because collecting, aggregating, and collating logs at scale is a very difficult problem. You've got a lot of data where you can quickly, depending on the number of requests your application is processing, reach into terabyte scale data every single day that you'd collect if you were collecting every single log line for every single request that your application gets. So what's the solution to some of these problems? AWS X-Ray makes it easy to identify performance bottlenecks and errors. And we'll see later in the presentation how X-Ray makes that easy. It makes it easy to pinpoint specific issues, so you know exactly which service in your application is causing these issues, where those issues are in the code. It makes it easy to identify the impact of these issues on your end users of the application. And finally, it enables you to visualize this terse data, log data, if you will, so that you can understand it much more simply. And it's visual. It's very easy to look at a graph and say, this is where the problem's at. So how does X-Ray help? So the way the X-Ray service works is you essentially have your application code where you include our SDK. What our SDKs do is they add filters, in essence, to your application to capture metadata about requests as they're being processed by your application. All of that data is then sent to our agent, which runs on your local host machine and acts as a local buffer. And then that ships it over to the service or the backend, where that data is then stitched together using a unique trace ID for every single request. Our SDKs also make it easy for you to propagate these trace IDs as you're making cross-service calls as part of your application. Once the data has been collected by the service, collated, and put together, or stitched together, I should say, into a trace, you can then do things like view a service map, which essentially gives you an aggregate call graph of all the services using the trace data that we just collected. So you can look at a service graph for the last 5 minutes, for the last 10 minutes, the last 5 hours, the last 24 hours. And what that really is a quick aggregate way to look at all the trace data that you've collected, which could be terabytes, if you will. And then finally, the process works somewhat like finding a needle in a haystack. So you've got this aggregate data on your call graph. And from there, you can continue to click in and dive deeper and find areas in your application where issues are occurring, and then actually get the reasons, including error messages, throttling issues, things like that. And we'll look at both the presentation and the demo how that happens. So as I mentioned, you start with our SDK, and you include it in your application. Available today is the X-Ray SDK for Java applications, .NET applications, and Node.js applications. What our SDKs do is essentially add filters to automatically capture metadata for calls to AWS services using the AWS SDK. We capture calls to non-AWS services over HTTP or HTTPS. We also have plugins that capture data from MySQL and Postgres drivers. And additionally, the AWS SDK captures data for Amazon DynamoDB. And we've also instrumented our SDK to capture specific information for queues using Amazon SQS. What all of this does for you is essentially it enables you to quickly get started without having to manually instrument your code. By adding about 7 to 10 lines of code, depending on how much information you want to capture, you can very quickly start getting this rich data set that we'll look at. I talked about the daemon. This is essentially our agent, which collects the data from the SDK over UDP. So again, everything about this service is built to operate at scale and to do it asynchronously. So we want to make sure that we're introducing minimal additional cost for your applications, both in terms of latency and performance. The daemon acts as a local buffer, and it flushes the data to the backend every second or when the buffer gets full. The daemon's available for the Amazon Linux AMI. It's available for RHEL, Ubuntu, OS X, and Windows. You can run the daemon pretty much anywhere where you can get AWS credentials. So you can do it on your desktop. You can do it on-prem. You could do it in EC2. You could do it in ECS using Docker containers. And Lambda support is coming soon. So that's something that we're working on. So let's talk about the concepts of the service, or what are the basic building blocks, if you will. So it's a tracing service, so obviously we have an object called a trace. The trace represents the end-to-end data that's related to a single request to your application. Now, a trace always starts at an origin service. So that's the first service in your application that's instrumented. And from that point forward, all the data that's related to that particular request is captured as part of that trace. And the reason we're able to do that is because our SDKs automatically inject a trace header, which has a unique trace ID. And then it propagates it through various services over HTTP, or if you're using queues, using message attributes in SQS queues. The data, or the trace, I should say, is sort of an ephemeral concept in that you don't input a trace into the system. What you get out of the system is a trace. What you put into the system are segments. Segments essentially are portions of traces that correspond to the metadata that was captured for a single service. This essentially allows us to have individual services sending us segments, and then the backend is essentially stitching all of this together and creating the trace for you. Segments then consist of subsegments, and what subsegments essentially represent are either remote operations that happen as part of a single service or local compute operations that you want to capture timing information for. We also have a notion of annotations. Annotations essentially is any arbitrary business data that's key value pair, and you have 10 annotations that are indexed. So you can filter on those annotations and search based on that data. We also have the capability to put additional metadata, if you will, that's added to the trace and is available when you look at a trace, but it's not something that you can filter traces on. We have a concept of errors. So our SDK essentially, anytime there's an error, it captures the stack trace and the message, and we'll see how it presents that on the UI. And we also have a notion of sampling. This is interesting from the perspective that, given it's a distributed tracing system, it takes a lot of data if you're not sampling. So essentially, think that you're capturing log lines for every single request that you get. And as I mentioned earlier, you could get terabytes of data every single day. Most of that data is practically useless for debugging purposes. What you need essentially is trend information, what's going on. And if you have issues, you can actually up your sampling rate to 100% and capture 100% of the data for a period of time that's appropriate. So it doesn't make sense to be capturing all the data all the time when it's not necessary. One of the other concepts on sampling in the service is essentially we allow you to do granular sampling. So as the example on the screen shows, you can, within a single service, set up rules to sample different paths differently. So if you have a billing path that is very important to you, you can choose to sample that 100%. Versus if you have a path that just shows your homepage that is not really that important to you, or you don't think that it matters to capture 100% of the data, where you can just get trend information, you can choose to do a lower sampling rate on that. So let's talk about the API for the service. The X-Ray API provides capabilities that enable you to send segments to the service, filter and retrieve trace data, and we'll see the rich filtering capabilities that we've built into the service. One of the things I want to mention is, given that we have support for Java, .NET, and Node.js today, the APIs actually allow you to send data from any application. The SDKs are simply making it easier for you to not have to do the instrumentation yourself. So if somebody's motivated, you can definitely go and write your own SDKs for various languages that you may want to write applications on. So you're not limited to the SDKs we provide. You can go write your own SDKs using our APIs. We also want to make sure that the raw trace data is available to you, because the way we look at the service is essentially solving the back-end problem of collecting and collating traces and then giving you insights on top of that data. So it doesn't make sense for us to not give you that data back for you to build rich applications or think of use cases that we may not have thought of. So there's a batch-get API where you can actually extract all your trace data, so you can export it into an ELK stack, if you will. You can put it in Splunk. You could put it in other different providers and search and continue to do the things that you do, except you have a very rich, normalized set of data that you're capturing as part of this service. One of the other things I want to mention about the API is the X-Ray service. We essentially see it as the service that will provide our partners that integrate with us the ability to look into other AWS services. So for example, when we have Lambda support, our partners can then get very rich information using this API on what the Lambda service was doing as part of every call stack. How many times did the Lambda function retry? What was the dwell time for the Lambda function? All of that information will be available for our partners and for our customers to build interesting applications and interesting dashboards on. And so let's look at what the APIs actually are. So it's a fairly simple service. We've got 4 APIs. You've got put trace segments that actually takes in a segment document, which is JSON data formatted to a specific schema, which we will make available later. We have batch get traces, which returns the traces to you in batches so that you can build applications, store that trace data wherever you want. We have get service graph, which returns the aggregate service graph as a JSON model so that, again, you don't have to use our visualization if you don't like it. You can take this data and build your own dashboard if you'd like. And then we have get trace summaries. This is essentially, from our point of view, the really rich filtering capabilities where you can go do things like show me traces that were between service A and service B that had HTTP URLs starting with the letter foo and had a status code of 200, for example. So you can get very granular in terms of finding issues or finding specific traces of interest. So let's look at what a segment documentation or document looks like. So as I mentioned, you send segments to the service. You don't send traces. So I've got a minimal example of a segment document. So as you can see, it has a name for the service. It has an ID. It has a start time. It has a trace ID. And it has an end time. So that's pretty much the smallest piece of information that you can send to the service and still get meaningful information about the timing of what happened there. We also have a concept of in-progress traces that let you track asynchronous requests. So you can essentially send us a segment from service A and say, I've queued my message. This request is in progress. And we'll show it to you on our UI as something that's in progress and it's pending completion on the other end. And when that completion on the other end happens, you can then go and mark the in-progress trace to false. And then that completes the trace. So let's look at the use cases. So the first use case is obviously visualizing the call graph. So in this example, you can see I have a 2-service system. I have a front end that has an API. And the API is using the SNS service from AWS to make notifications, or send notifications, I should say. And then we also have a DynamoDB table that we're writing data to. Now, what are the colors on that screen, if you will? And Werner mentioned it this morning. The colors actually represent family of status codes, HTTP status codes. So what you've got here is green represents the 200 and the 300 family of status responses. You've got orange or yellow, which represents the 400 family, which we call errors. And then you've got red, which represents the 500 family of responses, which are server-side errors, which we call false. In the middle of the nodes, you've got information about what was the average latency from all the traces we've captured as part of that service. And then you've got the number of traces or the rate at which we're capturing traces for that service. So what I can do on that screen, actually, is I can click on any of those nodes or services, or I can click on any of the edges that are connecting those services. So in this case, I actually clicked on the front-end service. So here you see I have all my traces essentially filtered by just the front-end service. I have a group by capability or aggregation capability on the top. And in the demo, we'll look at the different fields we can group by. And on the bottom, I have a list of traces that match that filter expression that I've entered here. In this case, show me all traces from service my frontend -dev. So in this case, I can very quickly switch that grouping to status codes. And by looking at the numbers, I can see that about 2% of my customers are impacted by 500 family of errors. And I can also see that about 49% of my customers are getting 409s. That's on purpose, and I'll talk to you guys why I did that for the demo. But that error code essentially means that there was a conditional check that failed when the request was sent to the service. So here I could click on either the 201, the 409, or the 500, and further filter the list of traces to only show the traces that match that criteria. So we just saw that how easy it is to identify impact on your end users for any given service and to be able to tell what's going on. Now let's look at identification of performance bottlenecks. So in this case, I did the same exact thing, chose my front end as a service. So in this case, I'm showing you the filter expression on the top. So the filter expression says service, my front end -dev, useast1.elasticbeanstalk.com. And by default, we group or aggregate the trace by URL. So I can go switch this and say, show me all traces that have the URL beginning with remote sign up. So that's where I'm making my remote call to the API, if you will. So that's been added to the filter expression as soon as I clicked on that. My trace list got filtered at the bottom, and then I sorted it by latency. So in the latency section, you can see that I have a trace that says it's 13 seconds long, and there are other traces that say it's 1.7 seconds. So this is a really bad API because it's taking a really long time, but 13 seconds is just unacceptable, right? So very quickly, I know I have a performance problem. So I click on that particular trace, and what I get is a timeline view of that exact trace. So in this case, you can see that my front end made a call to my API, and then in my API, I see that I made a call to Dynamo, and then once the Dynamo call succeeded, I made a call to SQS. Now, it's very interesting that Dynamo calls normally take literally milliseconds. So taking 12 seconds, something is wrong. So we'll go and click on that document icon, if you will, and we have a pop-up that pops up with additional data about that subsegment. So this is metadata, again, that our SDKs are capturing for you with just a single line code change on your application. So in this case, I move over to the Resources tab, and very quickly I get great information that the operation on the DynamoDB table was a put item operation. The table is in US East 1. I have a request ID that I can take back to the DynamoDB team if I need to debug this further. And then I see retries. So this is very interesting. I have 9 retries before that request actually succeeded. So obviously something is going on. So let's go ahead and look at a different representation of that error. So now I'm filtering by 409s. So similarly, I go in here, and in the case of 409s, as I mentioned, it's specifically for this demo, there's a conditional check that's failing. So when I go to the timeline view, I very quickly see these icons that are telling me there's something wrong. So I click on those icons, and then move to the Exceptions tab. And guess what that shows me? The actual exception that happened on my application while that code was running in production, and it gives me the entire stack trace of what happened. So looking at this, I know that on a particular line in my application, the conditional check when I wrote to DynamoDB actually failed. So again, being able to pinpoint issues exactly to the line of code and being able to then go and fix these issues very quickly is sort of the large value proposition of this service. So now let's talk about getting started. So we've shown you the cool things you can do with the service. Let's talk about what it takes for you guys to get started using the service. So the first aspect of starting with the service is the installation of the agent. Now this is a user data script that lets you install this in EC2 Linux systems, if you will. So simply just downloading the daemon from S3 and then running it. We've got EC2 Windows support. So this is a PowerShell script. You can essentially run this as a user data script. It'll do the same exact thing. And then on Amazon ECS, you can do the same thing with your containers. If you want to run this on your desktop, you can download the file from S3 and run it on your desktop. We have as I mentioned previously, support for RHEL, Ubuntu, Mac OS X, Amazon Linux, Windows, both as a Windows process and as a Windows service. And then in terms of the instrumentation for your application, all the data that you saw in the demo or the walkthrough that I just showed you guys is captured by just those changes, those code changes in your application. So what I've done here is I've added the X-Ray SDK package to my package.json. I go in and I initialize the X-Ray package. And then I put a capture AWS around the AWS SDK. That single line essentially lets me capture all calls to all AWS services that are made using SDK clients. Then I have some configuration where I'm essentially saying configure the EC2 plugin for the service. What that does is essentially tells the SDK to capture the metadata about the instance that's actually running the code. So automatically now you've got the EC2 instance ID, what AZ was running on. So if you have an issue, you can take this back and say this particular EC2 instance was running my code when this issue happened. One of the things that we don't show here is metadata or annotations, but you can think of interesting things you can do with metadata and annotations. So for example, if I was in a Java system and I was part of processing a request, I could add metadata around garbage collection. So if the garbage collector went off, I could add a metadata tag that says, oh, garbage collection was happening as part of this trace. So when somebody goes and looks at that trace, they can look at the metadata and say, oh, it makes sense. There's garbage collection, that's why there's high latency. And then we have those two lines on open segment and closed segment, which is essentially capturing all the express routes, if you will. So again, very simple, fairly easy to do. And we want to continue improving this as the service grows. We want to make this simpler, less essentially friction for you having to go automate, or you having to go instrument your code and automate more of this so that it happens automatically. Okay. All right. So now let's get to the fun part. Perfect. So essentially what I have here is the same exact graph that you guys saw on the PowerPoint, but we're going to do this live. So in this case, I have the service graph that you're seeing here is aggregated over the last 5 minutes. I could choose a different period, and then that's aggregated over that period. So I'll just stick with 5 minutes for now. And then here I have a bunch of red and yellow. I have some yellow here. I have all green here. So very quickly at a glance, I know that there's an issue with my DynamoDB tables. I know the name of the table. I know the name of my services. I know where my services are running. So in this case, you see EC2 instances. And then to start digging into this, I click here because that's the service with the most obvious issues, if you will. So I see that there's two requests or two URLs. One's essentially a blank URL. So if you run anything on the internet, you'll see these a lot. You'll see services pinging you with different CNAMEs that you weren't even aware of that will start showing up here. But what I want to do is look at status codes, because that's what I'm interested in. So here I see 201, 409, 500s. Obviously, I don't want 500s, because it's really bad for my customers. So I'm going to click on this. So what happened right there is automatically we added to the filter expression HTTP status is equal to 500. And then what you got here is a list of traces that just represent that set of filter criteria. So now I can see that all of these are taking somewhat the same amount of time. So let's go ahead and click on one of these and actually learn what's going on. So here again, I see I have these icons here. So that seemed to be OK, but that had a problem. And then that's where it seems to be the root cause of the issue. So again, very quickly, by looking at this, I can tell the error says error caused by provision throughput exceeded exception. So very easily, again, I know that I have a DynamoDB table that I didn't provision with enough IOPS that I need to go fix. But let's look at the additional data that we're capturing as part of that segment or subsegment, if you will. So you get some metadata about the segment ID, the subsegment ID. You have start and end time, duration, in progress state that we talked about for asynchronous calls. We have error and fault. So in this case, it was a 500 family of error code. So the error state is set to true. And then we have response. Actually, it was a 400 family, so that's why error is true and fault is false. And the response status is 400. So again, I get the same exact thing. And here I can see the number of retries is 10. So anybody who's used the AWS SDK, you'll know that the AWS SDKs automatically retry for throttling issues. They retry in the node case up to 10 times, and then they give up. So that's what you're seeing here. I don't have any annotations or metadata that I've added here, but I do have an exception that was captured from the SDK. And again, I can see that the exception happened on line 71 of my application. So very easy to get to the bottom of the issue, if you will. Let's go look at some of these other ones where I did add annotations. So in this case, I'm adding 2 annotations where what's the theme that my app is using when this user saw the application, and did they request preview access to my application. So one of the cool use cases regarding that is I can actually go in here, and I can say annotation.preview and annotation.theme. So if I click on this, I get all the values that we found for that annotation in the trace. So here we see, again, we're filtering by 500s, so not very interesting data, because we've already found the issue, if you will. So let's go ahead and change that. And now if you look at it, it seems like those using the Flatly theme happen to get a disproportionately high number, or somewhat high number, about 13% higher than any of the other themes. Now this could be that that's the most popular theme, if you will. It could be that there's something going on with that theme or the CSS. But again, the service is making it very easy for you if you're adding additional data, metadata, to get to the business problems of, if I'm running video, for example, or I'm running a video service, and I have a set of TVs that connect to my service. I can add annotations that has the model and the make of the TV. And if I have problems, I can very quickly, using this method, find out if it's a particular model of TV or if it's a particular make of TV where all the problems are happening. So again, being able to sort of very quickly get to the needle in the haystack, that's sort of the big value propositions of the service. Let's quickly look at some of the filter expression capabilities. So on filter expressions, we have a fairly rich capability. You can do simple things like HTTP URL contains, HTTP URL begins with, or you can do complicated things like give me traces between service A and service B that resulted in a fault that had an annotation with a key of foo and a value of bar, and that took longer than 5 milliseconds to complete. So that's sort of the level of querying capability that you have here to be able to filter and then get really to the crux of the problems that you're running into. And so some of the things to quickly review here, the SDK automatically captures, for example, the HTTP status, the URL, the method, the user agent, the client IP. We have a special user field where you can enter metadata about the users that may be using your application. So you can then go filter on that and see if only a particular user is impacted or if there are many users that are impacted. We've got the annotations that we talked about. And then you've got the ability to do a little bit of graph query, if you will, where you can say, show me traces for a given node, or show me traces for connections between certain nodes. So let's go back to the service map here. And then let's see what's going on here. So I've essentially got all my traces. I see latency between 25 seconds, if you will, for errors, all the way down. Actually, the numbers aren't there for this. Problems of live demo, if you will. But it's interesting that I have a 500 response with the same amount of time as a 201 response. So let's go quickly take a look at that. So everything looks green here, except my DynamoDB thing looks really long. I can, again, go click on this, look at this, go to resources, and there you go. I know very easily that this is happening because I'm retrying a ton of times. So again, I don't have a problem with my application. It's because of retries. I need to go solve that retry problem and not spend a ton of time trying to write additional logs, capture this data, figure it out for myself. So making it super simple. All right. The last thing I want to show you guys on the demo side is the raw data that I talked about. So again, this is available to you. We make it very visible, very prominent, because we want our customers and our partners to use this. What you've got here is essentially a JSON data model that normalizes the trace timing information. We've got some exception information that's captured, so we'll look at that. Actually, in this case, there was no exception, so let's quickly find a more interesting trace. So I will take the 500. And then I will just pick any one of those. So as you can see here, we've got the trace ID, of course, that's captured there. We've got timing information. We've got metadata about the service that's automatically added. So in this case, as you can see, I added the EC2 plugin, so I get sort of this metadata automatically added to my traces that has the EC2 information. We're working on plugins for other AWS services, so like Elastic Beanstalk, Lambda, so we'll automatically inject additional metadata there. I've got an HTTP section that captures data on HTTP requests. I've got my annotations here, and then I have the subsegments that represent that, the calls, I should say. And then finally, I have errors and exceptions. So in this case, error is set to true, and the exception is captured in a normalized fashion. So you can very easily use, or programmatically, I should say, go and look at exactly what line of code caused an issue, run interesting queries on this, and normalize to find out what sort of exceptions you're getting in your system. So really some good use cases here of the raw data. All right, let's quickly switch back. And let's see if that works. OK. So that sort of was an overview of the service. We'll talk about pricing quickly. The service itself is free during preview, so please go ahead and try us out as much as you like. After preview, the free tier for the service will include the first 100,000 traces that you record per month. That will be free. That's not for the first year. That's pretty much forever. The first 1,000,000 traces that are retrieved from the system or that are queried or scanned as part of the filters are also free per month. Beyond that, the additional charges that you would incur is $5 per 1,000,000 traces that you store in the system per month. And again, as I mentioned earlier, a trace represents a request to your origin service. So if you've got a microservices architecture that has a single request that comes in, fans out to 25 different services, and then comes back and goes out, all of that's actually captured as a single trace. So that's not 25 traces. It's a single trace. It's limited to 500 kilobytes. So a complete trace end-to-end must be 500 kilobytes. Given the data that you've seen captured that we showed you, it's a lot of data. What we have there was barely a few kilobytes. And then in terms of scanning or retrieving traces, you pay 50 cents per 1,000,000 traces that are scanned or retrieved from the service per month. So as I mentioned earlier, service is available today. Please go ahead and sign up for the service. There's a form. We'll get you whitelisted as soon as possible. I have links to documentation and sample applications, if you will, for all three, .NET, Java, and Node.js. And thank you very much for taking time today and being here. I wanted to end the session early so that you guys can go and enjoy the party. So thanks a ton. And please don't forget to complete your evaluations.